Friends, today I will tell you about something that made the best astronomers of the world literally freeze in shock. The planet Neptune that we knew for the last 30 years no longer exists. Those blue majestic images that hung in every astronomy textbook turned out to be just a beautiful illusion, artistic processing created by NASA engineers in 2023 when the James Webb Space Telescope and the most powerful ground-based observatories pointed their mirrors at the eighth planet from the sun. They saw something completely different. The real Neptune turned out to be a pale, ghostly world with disappearing clouds, hurricanes that violate all laws of physics, and an internal heat source that should not exist. Scientists realized that we completely do not understand this ice giant, and that our models of planetary evolution require a complete revision. Today, I will immerse you in the darkest secrets of Neptune and tell you why each new discovery makes astrophysicists nervously clench their fists. To understand the scale of the shock, we need to go back to August 1989. It was then that the legendary spacecraft Voyager 2, after a 12-year journey through the entire solar system, finally reached Neptune. This was a triumphant mission, the culmination of one of the greatest engineering achievements of mankind. The apparatus flew only 5,000 kilometers above the clouds of the planet, and its cameras began transmitting images. The world held its breath when it saw the result. A stunning blue planet appeared on the screens, the color of which was so saturated and deep that Neptune instantly became the calling card of distant space. But here is what no one told you. In those years, NASA engineers received black and white images with different light filters and began to combine them to create a color image. In the process of this work, they faced a problem. The real color of the planet was too dim, too unexpressive for the public that was waiting for a miracle. Therefore, the image processing team decided to enhance the blue channel, increase contrast and saturation. This was standard practice for scientific visualization. The goal was to emphasize details of clouds and atmospheric structures to make them visible for analysis. No one was going to deceive the public. It was a technical necessity, but the result was unexpected. The retouched image of Neptune became canonical. It was replicated in millions of copies, appeared in all encyclopedias, textbooks, documentaries. An entire generation of astronomers grew up with this picture in their heads, and most importantly, it was on the basis of these processed images that the first models of Neptune's atmosphere were built. Scientists analyzed color, brightness, details, and drew conclusions about the distribution of methane, hydrogen, helium in the upper layers of the atmosphere. 30 years later, when technology stepped forward, when new instruments appeared capable of seeing Neptune in its true light, the moment of truth came, and this moment turned out to be shocking. December 2021, the James Webb Space Telescope, the most expensive and complex instrument ever sent into space, successfully deployed its giant 6.5-meter mirror and began calibrating systems. By mid-2022, it was ready for scientific observations, and one of the first targets was Neptune. At the same time, ground-based observatories, equipped with adaptive optics systems that compensate for distortions of the Earth's atmosphere, also pointed their telescopes at the ice giant. Adaptive optics is a revolutionary technology that uses deformable mirrors, changing their shape thousands of times per second to neutralize air turbulence. Thanks to this, ground-based telescopes can now obtain images of almost the same quality as space ones. When the Very Large Telescope in Chile and the Keck Telescope in Hawaii received their first images of Neptune in new resolution, astronomers did not believe their eyes. The planet looked completely different. Instead of a saturated blue color, they saw a pale, grayish-bluish ball. Instead of bright cloud belts that should have encircled the planet, the atmosphere seemed almost faceless. But the most shocking thing was that the bright methane clouds that were regularly observed in previous decades almost completely disappeared. The first reaction was disbelief. Scientists checked the calibration of instruments, reviewed the data, contacted colleagues from other observatories, but everything was confirmed. The clouds really disappeared. Dr. Patrick Irwin from Oxford University, one of the leading experts on the atmosphere of ice giants, later admitted that when he saw this data, his first thought was we have fundamentally misunderstood something all these years. Methane clouds are formed when methane rises from the lower layers of the atmosphere, cools, and condenses at high altitudes. Their disappearance meant that either methane stopped rising or the temperature structure of the atmosphere radically changed, but none of the existing mechanisms could explain such a rapid global change. This was like if on Earth all cirrus clouds suddenly disappeared simultaneously across the entire planet. Now, let us talk about the winds of Neptune, because it is they that represent one of the most mysterious phenomena in our solar system. Measurements made by Voyager 2 showed that Neptune has the fastest winds among all planets. The speed reaches 2,100 kilometers per hour. This is almost 2 times faster than the speed of sound in the Earth's atmosphere. For comparison, the most powerful hurricane ever recorded on Earth, Typhoon Tip, in 1979 had a maximum wind speed of about 305 kilometers per hour, and this hurricane received energy from a warm tropical ocean from powerful solar heating. And now imagine Neptune is located 30 times farther from the sun than Earth. At such a distance, solar radiation weakens by 900 times. The temperature at the tops of the clouds is about minus 220 degrees Celsius. There is practically no solar heat there. According to all laws of meteorology, winds on such a planet should be weak, sluggish, barely noticeable movements of gas, but instead we observe a real atmospheric hell. Hurricanes that tear clouds to shreds, gas flows rushing at supersonic speed. Where does the energy come from? This is the main question that has tormented planetologists for 35 years. The only logical answer is energy must come from inside the planet. And indeed, infrared measurements show that Neptune radiates into space approximately 2.6 times more energy than it receives from the sun. Inside this icy world, some kind of most powerful engine is working, a heat generator that heats the interior and creates convective flows. These flows rise from the depths of the mantle, pass through thousands of kilometers of compressed ice and gas, and finally break into the atmosphere, where they create zones of ascending and descending movements. The temperature difference between these zones launches the circulation of gases. Winds are formed that accelerate due to the rotation of the planet. The Coriolis effect twists the flows into giant spirals. But even taking into account internal heat, the mathematics still does not add up. Computer models of atmospheric circulation show that to create winds with a speed of 2,000 kilometers per hour, you need an energy source much more powerful than the one we observe. This means either our models are incomplete or something is happening inside Neptune that we do not even suspect. One of the most eerie features of Neptune is dark spots, giant storm systems that appear and disappear like ghosts. The first such spot was discovered by Voyager 2 in 1989. It was about the size of Earth, a dark oval vortex in the southern hemisphere of the planet. Scientists called it the Great Dark Spot by analogy with the Great Red Spot of Jupiter. On Jupiter, the Great Red Spot has existed for at least 400 years. It is a stable, long-lived structure, an anticyclone that feeds on energy from the lower layers of the atmosphere. Astronomers expected that the Great Dark Spot of Neptune would behave in a similar way, that it would exist for decades or even centuries. But when in 1994 the Hubble telescope looked at Neptune again, the spot disappeared. It simply dissolved in the atmosphere without a trace. This was the first alarm bell. Why did a vortex of such a scale simply disappear? Where did its colossal kinetic energy go? Scientists suggested that perhaps the vortex moved to another hemisphere or was destroyed by vertical movements of gas, but there was no exact answer. And then in 2018, Hubble discovered a new dark spot, this time in the northern hemisphere. Astronomers began to observe it, to track its evolution, and then something incredible happened. The spot began to drift towards the equator. According to all models of atmospheric circulation, when such a vortex approaches the equator, it should weaken and eventually disappear, because the Coriolis effect at the equator is zero, and the vortex loses stability. But the Great Dark Spot of 2018 did not disappear. Instead, it suddenly turned around and began to move back towards the pole. This was impossible. The vortex behaved as if it were a living organism that made decisions, avoided danger, and sought a safe place, meteorologists were shocked because no existing theory could explain such behavior. In 2021 and 2023, new dark spots appeared, each with its own unique trajectory and lifespan. It seemed that the atmosphere of Neptune is not a deterministic system governed by physical laws, but a chaotic, unpredictable environment where each storm lives by its own rules. And this is scary, because if we cannot predict the behavior of storms on a planet that we have been observing for 35 years, then how can we hope to understand exoplanets at a distance of tens of light years? And now let us talk about the biggest mystery of Neptune, about its internal heat source. As I already mentioned, the planet radiates 2.6 times more energy than it receives from the sun. This is a huge anomaly that requires explanation. At first glance, there are several possible sources of such heat. The first option is residual heat from the formation of the planet. When Neptune formed 4.6 billion years ago, the gravitational compression of gas and dust released a colossal amount of energy. The planet was red hot. After that, it began to cool slowly, radiating heat into space. Jupiter and Saturn still radiate residual heat from their formation, but Neptune is much smaller than them and should have cooled much faster. Calculations show that residual heat is not enough to explain the observed radiation. The second option is radioactive decay. In the core of Neptune, there may be heavy radioactive elements like uranium and thorium that slowly decay, releasing heat. But again, the scale of energy does not add up for radioactive decay. To explain the observed luminosity, the core of Neptune must contain an incredibly large amount of radioactive elements, much more than models of planet formation predict. The third and most intriguing option is chemical differentiation and phase transitions inside the mantle. Imagine that in the bowels of the planet, at a depth of thousands of kilometers, at a pressure of millions of atmospheres, and a temperature of thousands of degrees, processes of separation of matter occur. Heavier components sink to the core, lighter ones rise up. This process is called gravitational differentiation, and it can release a huge amount of energy. In addition, at certain pressures and temperatures, substances undergo phase transitions. Water turns into superionic ice, methane decomposes into carbon and hydrogen, and carbon crystallizes into diamonds. Each of these transitions is accompanied by the release or absorption of energy, and if such processes are constantly going on inside Neptune, if there's a complex multi-layer structure with convective flows, chemical reactions, and phase transitions, then this could explain excess heat release. But the problem is that we do not know exactly what is happening in the bowels of Neptune. All our knowledge is based on indirect data: gravitational field, magnetic field, infrared radiation. We build models, make assumptions, but we have no direct evidence, and each new model leaves questions unanswered. Now let us dive into one of the most fantastic hypotheses about the interior of Neptune, the hypothesis of diamond oceans. In 2017, a group of scientists from the SLAC National Accelerator Laboratory in California conducted a revolutionary experiment. They took a mixture of hydrocarbons similar in composition to the interior of ice giants and subjected it to the action of a powerful laser, which created a pressure above 1.5 million atmospheres and a temperature of about 5,000 degrees Celsius. Conditions similar to those that exist at a depth of about 10,000 kilometers below the surface of Neptune. The results were stunning. Under such conditions, hydrocarbons began to decompose. Carbon separated from hydrogen and crystallized in a microscopic diamond. Scientists literally, with their own eyes, observed the formation of diamonds under laboratory conditions, simulating the interior of planets. This proved that the hypothesis of diamond rains is not just a fantasy, but a real physical process. Imagine this picture at a depth of several thousand kilometers below the visible surface of Neptune. In pitch darkness, at monstrous pressure, methane, which makes up a significant part of the mantle, begins to decompose. Carbon atoms line up in crystal lattices, forming diamonds. These diamonds, ranging in size from a speck of dust to a hailstone, begin to slowly sink, descending deeper and deeper to the core of the planet. This is literally a diamond rain that goes on not for minutes or hours, but for billions of years. Continuously falling diamonds accumulate at the boundary of the mantle and core, forming at the bottom of the mantle entire oceans of liquid carbon. At even higher pressures closer to the core, diamonds can melt, turning into a liquid form of carbon that does not exist in nature on Earth. This hypothesis explains a lot. First, the fall of diamonds releases gravitational potential energy, which turns into heat. This may be one of the sources of excess thermal radiation of Neptune. Second, the process of separation of carbon and hydrogen changes the chemical composition of the mantle, which affects convective flows and the magnetic field. Third, the existence of liquid diamond layers in the interior creates additional complexity of the internal structure, which can explain the oddities of the magnetic field, which I will talk about later. But how real is this hypothesis? The fact is that we will never be able to send a probe into the bowels of Neptune to test it directly. No material will withstand such pressures and temperatures. All we have are laboratory experiments, computer models, and indirect observations. But with each year, there is more and more evidence. And today, most planetologists believe that diamond rains really go inside Neptune and Uranus. Now let us talk about an even stranger form of matter that exists in the bowels of Neptune. About superionic ice. Ordinary ice is a crystal lattice where water molecules H2O are orderly arranged and practically motionless. When you heat ice, it melts, turns into liquid water where molecules move freely. And if you continue to heat, water evaporates, becomes steam. But at extreme pressures that exist inside Neptune, water behaves completely differently. At a pressure above 2 million atmospheres and a temperature of several thousand degrees, water transitions into a state called superionic ice. In this state, oxygen atoms form a solid crystal lattice like an ordinary ice, but hydrogen atoms break away from their molecules and begin to move freely between oxygen atoms like electrons in a metal. This means that superionic ice is simultaneously solid and liquid. It has a crystal structure, but at the same time conduct electric current. Because mobile hydrogen ions carry charge, this state of matter was predicted theoretically back in 1988, but was experimentally confirmed only in 2018, when scientists managed to create superionic ice in the laboratory using powerful lasers and diamond anvils. Why is this important for Neptune? Because a significant part of the mantle of the planet probably consists of superionic ice. And since this ice conducts electricity, it plays a key role in generating the magnetic field of the planet. On Earth, the magnetic field is created in a liquid iron core, where convective flows of molten metal create electric currents, and they in turn generate a magnetic field. On Neptune, the mechanism is different. Electric currents flow through superionic ice in the mantle and not in the core. And here is what makes this truly strange. The magnetic field of Neptune is displaced relative to the center of the planet by as much as 0.55 of the radius of the planet. In addition, the axis of the magnetic field is tilted 47 degrees relative to the axis of rotation. This creates a completely asymmetric, chaotic magnetic field. When the planet rotates, this skewed field rotates with it, creating the effect of a rotating magnetic whip. The magnetosphere of Neptune is one of the most complex and dynamic in the solar system. It constantly changes, pulsates, captures charged particles from the solar wind, and accelerates them to near light speeds, creating zones of killer radiation. Any spacecraft that tries to approach Neptune will face this radiation hell. Electronics will fail, solar panels will degrade, sensors will go blind. This makes the study of Neptune an extremely difficult task, requiring special radiation protection and careful trajectory planning. And now let us return to the most recent and frightening discovery, to the connection of Neptune's cloudiness with the solar cycle. In 2023, a group of astronomers led by Aaron McDonald from Harvard University published a study based on 30 years of observations of Neptune using the Hubble telescope. They found that the number of bright clouds in the atmosphere of Neptune correlates with the 11-year cycle of solar activity. The sun lives in cycles. Every 11 years, the number of sunspots reaches a maximum. Solar flares and coronal mass ejections become more frequent, and powerful ultraviolet radiation intensifies on Earth. This causes aurora's magnetic storms problems with satellites and radio communications. But Neptune is located 30 times farther from the Sun than Earth. At such a distance, solar radiation weakens by 900 times. Logic suggests that solar activity should not have a serious impact on the atmosphere of a planet that receives a negligible amount of solar energy and is powered mainly by internal heat. But the data shows the opposite. When solar activity reaches its maximum, the number of bright methane clouds on Neptune increases sharply, and when activity drops, clouds disappear. This is exactly what happened in 2023. The Sun entered a new cycle of activity, and the clouds on Neptune almost disappeared. The correlation is so clear that it cannot be a coincidence. But how is this possible? Scientists suggest that the ultraviolet radiation of the Sun triggers photochemical reactions in the upper layers of the atmosphere of Neptune. Ultraviolet destroys methane molecules, creating more complex hydrocarbons, which then condense, forming haze and clouds. When ultraviolet radiation intensifies during the solar maximum, photochemistry accelerates and clouds become more. It sounds logical, but there is a problem. The intensity of ultraviolet at the distance of Neptune is so small that photochemical reactions should go extremely slowly. The effect should be barely noticeable, but instead we see dramatic changes, the complete disappearance of cloud cover in a few years. This means that the atmosphere of Neptune is incredibly sensitive to external influences, much more sensitive than we thought. And this is scary because if such a distant cold planet can react so strongly to changes in solar activity, then what will happen to it if the Sun enters a period of abnormally low or high activity? Can this cause catastrophic changes in the atmosphere, destroy existing circulation patterns, create new giant storms? We do not know, and this ignorance is disturbing. Now let us talk about Triton, the largest moon of Neptune, because its story is a story of a slow cosmic catastrophe. Triton is unique. It is the only large satellite in the solar system that orbits its planet in the opposite direction, retrograde. All other large satellites, including our moon, rotate in the same direction as their planets, but Triton moves in the opposite direction. This unambiguously means that Triton did not form together with Neptune. It was captured by the gravity of the planet. Most likely, Triton is a dwarf planet from the Kuiper Belt, that distant icy region beyond the orbit of Neptune, where objects like Pluto lived billions of years ago. Triton flew past Neptune too close, was captured by gravity, and became a satellite. But capture is not a gentle process. When Triton was caught, its orbit was highly elongated, elliptical. The gravity of Neptune constantly stretched and compressed the satellite, creating tidal forces that heated its interior. This process is called tidal heating. Gradually, the orbit of Triton became more and more circular, but tidal heating continues to this day. And here is what is surprising. Despite the fact that Triton is located in one of the coldest places in the solar system, where the surface temperature is minus 235 degrees Celsius, there are active geysers on its surface. Voyager 2 discovered them in 1989. These geysers eject nitrogen and dust to a height of up to 8 kilometers. This means that under the ice crust of Triton, possibly several kilometers thick, there is liquid water, a subglacial ocean heated by tidal heating. A subglacial ocean is one of the most promising places to search for extraterrestrial life in our solar system. Jupiter's moon, Europa, also has a subglacial ocean, and NASA is planning to send the Europa Clipper mission there. Triton could be an equally interesting target, but there is a huge problem: radiation from Neptune's magnetic field. Triton is located only 355,000 kilometers from the planet, deep inside the magnetosphere. It is constantly bombarded by charged particles that destroy surface ice, create an exosphere of nitrogen, and slowly destroy the satellite itself. Any mission to Triton will face the same problem of radiation exposure as a mission to Neptune. But the darkest thing is that Triton is doomed. Its retrograde orbit means that it is slowly approaching Neptune. Every year, the distance decreases by about 1 centimeter. this seems like a negligible amount. But in a few billion years, Triton will cross the Roche limit, the critical distance at which the tidal forces of the planet will tear the satellite apart. When this happens, Triton will break up into thousands of fragments that will form a giant ring system around Neptune, possibly the most impressive in the solar system, eclipsing even the rings of Saturn. But this will mean the end of Triton as a world, the end of its subglacial ocean, and any life that could exist there, a slow cosmic execution that will stretch over billions of years. Friends, we have come a long way from the blue illusion of Voyager to the frightening reality of modern observations. And now, I want to summarize Neptune is not just a distant planet on the edge of our system. It is the key to understanding an entire class of worlds, ice giants of which there are billions in our galaxy. Every discovery related to Neptune undermines our ideas about how planets should behave, winds that should not exist, a heat source that we cannot explain, storms that appear and disappear like ghosts, a magnetic field that behaves like a living thing, clouds that react to solar cycles, although they should not, diamond oceans in the interior, and superionic ice conducting electricity. All this tells us that planets are not simple objects that can be described by a couple of equations. These are incredibly complex dynamic systems where dozens of processes interact, creating feedback loops that can amplify or dampen in unpredictable ways. And here's what is really scary. If we were so wrong about Neptune, a planet that we have been observing for 35 years, to which we sent a spacecraft, which we could see in telescopes, then how accurate are our models of exoplanets? We have already discovered more than 5,000 planets around other stars, many of them are ice giants similar to Neptune. We analyze their atmospheres. By spectra, we build models of their climate. We evaluate their potential for life. But maybe most of our conclusions are wrong. Maybe we are missing key processes, underestimating the influence of the star, misunderstanding the internal structure. Neptune shows that even in our own cosmic backyard, there are worlds that challenge our understanding. The next mission to Neptune is scheduled no earlier than 2040. This is almost 20 years of waiting, but when it finally launches, when a new probe equipped with modern instruments enters this system, I am sure we'll discover even more mysteries, because the deeper we look, the more we understand how little we know. Neptune is a reminder that the universe is full of wonders and horrors that we are only beginning to comprehend. This is a call to humility for science, which is sometimes too confident in its models, and this is a promise of incredible discoveries that await us ahead. Thank you for being with me on this journey into the icy abyss, where the laws of physics manifest themselves in the most extreme and frightening forms.